There you go. No.
Imagine if Friday the
I'm with
13th was on Halloween.
The only time that happens is when you're my friend Mark Christensen and you announce to everybody, hey, my birthday's going to be on Halloween this year. And we all kind of stop and look at him going, Halloween's October 31st. So you're born October 31st? He's like, no. and he couldn't answer the question, so you're just trying to look at him going, I don't get it. All right.
Imagine if Friday the 13th was on Halloween.
Huh?
Yeah, probably.
It is.
I'm dead. Halloween was Friday.
Oh, if it was October, that'd be kind of cool. I guess it's on October 31st, so the dyslexic people think it's on October 13th. Oh, that's not funny. He's making fun of me. All right. Let's go through this review, see how we do. So this was the review that I had asked you to work on, yes? And we said it was due by the end of today, so let's just make sure we're going well with it. Guys and girls, well, it's in the pack worksheet.
Holy shit.
It's in the book. All right, so what kind of, and I'll tell you what, a lot of the stuff that is on the test will be very, very similar to how these questions are set up. So, yo. 153-ish? 153? And Casey, if you need to take a picture of it, Mac has it open so you can take a look at his real quick if you need to come take a picture. All right. So this first one, what kind of function is this? Quadratic. We good with that? The range, give it an interval notation. The range goes in which direction? In the x direction, which is right, left, or up, down in the y direction? The y direction, so it goes up, down. So our range will start, yeah, it looks like about -4.5, right? So it goes from -4.5 all the way to positive infinity. What do you think? Everyone with me? What does the vertex appear to be? 0.5, I like it. And -4.5? What are the roots? -1 and 2. So you can list it as -1 and 2. Or you could list it like this. They both mean the same thing in my opinion, okay? So one means you have a point, one means you have the root. We okay so far? I can't remember. Does PDF move down with me? Nope. All right, I got to clear ink. Clear in the ink. Everyone okay with those answers? All right. What is the y-intercept? Okay, the y-intercept label as a point. If you put -4, you're technically correct, but I'd like it to be put as a point because you have to realize it is indeed a point. But if you just list it as -4, I'll still give it to you. If it was a multiple choice, it would have 0, -4 as an answer. So don't goof up with that. What interval is the graph decreasing? So it's decreasing here. So it's coming from, in the x direction, it's decreasing, 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 decreasing. So it's coming from -infinity, and it's getting to 0.5. Remember, it's talking about what is it doing in the x direction. And then letter G says, well, on what interval is the function positive? Okay, so the positive portion of it deals with this. Here and here. Those are both above the x-axis. That's where it's positive. So there's two regions that works from. So it goes from -infinity to -1. And it also goes from what to infinity? Start there or there? 2. Okay? So on what interval for x, so we're talking about the x component, is it above the y-axis? Okay? Or above the x-axis, excuse me. So from -infinity to 1, it's all above the x-axis. And from 2 to infinity, it's also above the x-axis. We okay? That one just goes to letter G. Cool. All right. Can I clear?
Yeah.
Yeah. No, it'd be rounded, and this is why. Because once you get to right here, it's not increasing or decreasing. It's actually a slope of 0. So the increasing and decreasing means basically, remember we were talking about rate of change? If the rate of change is negative, it's decreasing. If the rate of change is positive, it's increasing. That's really the whole network of the increase and decrease. Can I clear this?
Yeah.
And I'm recording it as well, so this would be good stuff if you needed to go back and watch to help you out. Okay, next page. All right. What kind of function is it? Linear. What is the root? Where's it across the x-axis? 2. So as a point, so you can list it as 2, or you could list it as 2, 0. Again, you choose how you want to list it. I understand both. We good on that? What is the y-intercept? I'd say on this one, it does appear to be -4. Okay? Though we can't see it, just extrapolate it a little bit and say, I'm pretty sure it's going to be 0, -4. Where is the graph increasing? Is the slope of this line positive or negative? It's positive, so where's it increasing? There you go, from negative infinity to positive infinity. The reason we know that is because the slope and the rate, or which is also called the rate of change, of a straight line stays constant. It's the same throughout the entire line. And then on what interval is the function positive? So we're going from here on up. That's where it's positive. So where in the x do we start? 2. So that could be a square bracket. So from 2 to infinity. I guess you could technically call it a rounded bracket. Because at 2 it's actually at 0, and 0 is signless. So 2 to infinity. If you put the square bracket, I'm not going to dink you for that. We good? Everyone feel okay? What? Oh, I'm sorry. I make it better than all I do. I got my hair cut yesterday. I don't know if you guys noticed.
Oh, one hair.
What hair? You got that right, buddy. Yeah. All of you gentlemen that have great hair, which is all of you right now, enjoy the great hair. Some of you might be blessed like me to recede it and thin it. But just go
trim it a little bit.
Just go with it. It's okay. I'm the same person regardless. I always look at myself knowing I still have that beautiful wavy blonde hair that I used to have. I understand when I look in the mirror, I don't see it all the time.
It's there on my heart.
It's my heart. It's my memory. It might grow. You have a hairy heart. All right, can I clear? We good?
Yeah.
Feel all right? All right, cool. Clearing the ink. Let's move on down. All right, what kind of function is this? Exponential. Okay. What is the range? The range is going the up and down, correct? So it's going up to infinity. Almost. Which one is it? -1. So it's going from rounded bracket -1 to infinity. Now the reason this one's -1 is because it will not cross over the horizontal line y equals -1. Y equals -1 is called a horizontal asymptote. So it's a rounded bracket on this because it will not cross over. It'll get really close to it but never get to it. What are the roots? Well, it looks like it's crossing about right there, so I would say -1, 0. Okay? Realizing this -1 is not the same thing as this. We're talking about two different -1s. We're talking about either the x or the y one. What is the y-intercept? Y-intercept looks like it's about there, so that would be at 0, 1. Okay? On what interval is the function negative? Okay? So remember, so this line was generated basically by an infinite amount of these types of lines. So are they all positive, all negative, or none? Yeah, we got Stevie. Wait, say that one more time. So, well, here's the thing. These are all positive slopes. So no matter where on that line you fall, it will be a positive slope. So some places it'll be really close to a horizontal line, but it still has somewhat of a positive slope. So being this is in exponential growth would mean that the interval, it's not going to have any negative. On what interval is for x is the function negative? Oh, wait. Did I not answer? Oh, I didn't answer the question. Shoot. On what interval for x? I thought it was x for h. I'm sorry. On what interval is x the function negative? So let me just change colors. So right here is where it's negative. So in the x direction, it's going to come from negative infinity and get all the way up to -1 rounded bracket. Oh, I could flip this over. Well, I would take this as an answer totally. Either way, it's going to be the same thing. Growth or decay? Growth. It's growth. Cool. So that's how we do that problem. Feel okay?
Yes.
Yeah. Can I clear it?
Yes.
Yeah.
Yes.
All right. Let's move on down. Oh, here we go. You will definitely see this type of problem on the test. We need to fill out the graph. So this makes a straight line. Do you agree?
Yes.
Straight line means it's a straight line when you graph it, right?
Yes.
Don't put a curve in there. Okay, so you're going to take each value, plug it in. I'm pretty sure you know how to fill out a table, but we'll just walk through it. 2 times -6 is -12. -12 added to 4 is -8. Still with me?
I am on the wrong page.
It's 155, I believe. Uh-oh, I hear the fire trucks. Another guy get hit by a car on a bike. All right.
What happened to that?
I don't know. He was gone. All right.
By the time they were there.
Yeah, the hearse pulled up there. He was, yeah, I got it. All right, I'm just kidding. All right, 2 times -3 is -6. -6 added to 4 is -2. Careful on your signs. 0. 2 times 0 is 0. 0 plus 4 is 4. Sweet. 2 times 3 is 6. 6 added to 4 is 10. 2 times 6 is 12. Add 4. 16. Okay. There are some of those that won't fit on the graph, and that's okay. So, -6, -8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. -3, -2. 1, 2, 3, 1, 2. 0, 4. 1, 2, 3, 4. And I guess 3, 10 would also fit. So 3 and then 10 is all the way up here. Okay. There's our line. Goes through those dots as best we can. Sketch the graph. We did that. That's done. What is the x-intercept? Oh, I don't know. Is it -2? It actually comes out to -2.
Yeah.
So if I had my graph drawn right, my x-intercept would be 0 or -2, 0. Okay, now if you can't get that right away, this is how you solve it. You plug 0 in here, and you solve this. So subtract 4, then divide by 2. So subtract 4, you get -4 equals 2x. Divide by 2, so you get x equals -2. That's the same way. What is the rate of change from -6 to -3? So that's on the bottom. So -6 minus 3. The value for -6 is 16. Minus the value for -3 is -2. Do you agree with that?
Yeah.
And then what I can do is I can change these signs, plus, 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 plus. So on top I get 18, and on bottom I get -3, which reduces to -6, or -6/1, your choice how you want to write it. That wasn't too tough, was it? How's the review going? Is it okay? Everyone with me? Gage is sleeping, so I'll hold it down a little bit. May I clear the ink? Okay, what kind of function is this?
Wait, Mr. Strip, can I just ask a quick question?
Yeah.
So for the last problem where it was like the -6 and the -3, was it 16 or was it -8?
I don't remember. I cleared the ink.
Oh, because I think you put down like 16 -2, but I think you used the +6.
Oh, did I? I
Yeah.
went backwards. Okay.
Because I was just like, wait a minute, then wouldn't you have to move like the -3 onto the left and then the -6 onto the right?
Yeah, let's see if I can regenerate.
Sorry, I just want to make sure because I don't want
Let's
to
regenerate. Alright, can I undo it? Is there an undo up here?
Yeah.
Where?
Oh, wait, it was a -8, then -2, then 4, 10, 16.
Here, help me here. What was the -6 value?
-8.
-8. What was the -3 value?
-2.
-2.
And that's all you
Oh,
need to know.
did I choose this value?
Well, you did the number, you did -3, but you did +6.
So, is that what it's supposed to be?
No.
No?
When you have to move the -3 onto the left and then the -6 onto the right.
So, this is the slope equation, y2 minus y1, x2 over x1, right?
Yes.
So, basically, I'm going to go from here to here. Still with me?
Yes.
So, from here to here, same idea?
Yep.
That minus comes along, you still with me? So, the value for the -6 was the -8. So, I'm going here to here. So, that would have been plus, 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 plus. -6 over, oh, shoot. That's over -3. So, is that it? Was that, oh, I made the error.
Yeah, wait, I was going to say, the y2 is -3, right?
Well, it doesn't matter. I can label this as x1, y1, and x2, y2. Or I could label this x1, y1, x2, y2. It's the exact same answer regardless. As long as you keep the x2s and the y2s together and the x1s, don't flip-flop them.
Okay. I always thought it was like -3 -6 as like for the x.
Mhm.
Then for like the y2 minus y1, I thought it would have been -2 minus -8.
So if I flip-flopped them, basically this would have turned out to be plus plus like that,
Yes.
which still gives me an answer of 2.
Okay.
So if you flip them, if these are flipped, don't flip these and then not flip those. Does that make sense? So
Yeah.
keep it consistent how you label them.
All right.
Clearing the ink. Sorry about that. I didn't mean to goof that up. I went too fast. I'll tell you. I might have fallen off my bed or something last night. All right. Exponential.
Would not.
Huh? Don't you guys fall out of bed still? I do. I have a rail that's up. Oh. One thing I do need to get though is I need to I do need to get some sort of alarm on my doors because I do sleepwalk and I have wound up outside. What are you doing there, Sunshine?
I'm thirsty. I get water.
I think you're screwing around. You get your phone out.
What?
You guys playing slap and tickle?
It's spanking tickle.
I like saying slap and tickle.
Just take this for the rest of the day.
Cupcake.
Trying to hide his. I need your student ID, please. I need your student ID, please. You better generate it. It's going to be pretty hard to get your phone back from the dean. Yeah, your phone's right there. That's your phone? Why does he have your phone? Whose phone's that one? Oh. Why'd you get his phone taken away? Why are you using his phone? No, don't act all innocent. Quit being like the French and act like it's everyone else's fault. You were caught red-handed. You can't leave it hidden in a calculator cap like that.
Especially if it's not yours.
Poor George is without a phone now. Man, if I was George, I'd be a little frustrated with you. George, being old sunshine over there, stole your phone, and you were unaware of it. You're more than welcome to get your phone back at the end of the period from my desk. Is it really your phone, George?
Yeah.
Okay.
I'm on the cover.
Huh? No applause, no applause. Just throw money.
Just because of
He's not sure.
All right, completing the table.
that.
This is exponential, so this does not look like a straight line. Still with me? All right. Shh. So what I'm going to do is I'm going to take -2, plug it in, so I get 4 times 2 to the -2. This becomes the same thing as 4 times 1 over 2 squared, yes? Which is 4 over 1/4, which is? What's 4 times 1/4? 1. Okay? So then if I take -1, plug it in, I get 4 times 2 to the -1, which is the same thing as 4 times half to the first, which is 4 times half. What's half of 4? 2. If I plug 0 in, 4 times 2 to the 0. 2 to the 0 is how much? 1. 4 times 1 is 4. If I plug 1 in, I get 2 to the first, which is 2. 4 times 2 is? 8. If I plug 2 in, 2 squared is?
16.
Yeah, I get 16. Sweet. So 2 comma 16 probably won't fit on the graph. Agreed?
Yes.
So I get -2, 1, -2, 1. I get -1, 2. I get 0, 4. And I got 1, 8. So that's what that graph looks like. Still with me? Sketch the graph. We did it. What is the y-intercept? 0, 4. Right? What is the equation of the horizontal asymptote? What does it look like it's not going to cross?
0.
0. So it is the line y equals 0. Remember, y equals 0, or y equals a number, will be a horizontal line. So the horizontal line, this horizontal line is right here. That's the asymptote. So the red line approaches the green line. It will not cross it. It will not touch it. What is the rate of change from -2 to -1? Now, the rate of change on this whole thing would be different between two different sets of points. They're just asking you for one set, so I can go -2 minus -1, and then the -2 I get 1 minus -1. Oh wait. 1 minus 2. Thank you. 1 minus 2 is -1. Shh. That's positive. -2 plus 1 is -1. -1 over -1 is 1. So that means that the slope from here to here, that's what's going on. That's what the slope is. Shh. So that's what the rate of change is. Okay? Woo! Good problems. I love it. Clear this? Number 6, quadratic, yes? Because it's x squared, yes? Let's complete the table. I don't think we have to do this too much. -2 quantity squared is 4, plus 10, plus 4. Excuse me. 18, thank you. And plug -1 in, I get 1, plus 5, plus 4, 10. Is that right? And then plug 0 in. So 0 gives me 4. If I plug 1 in, 1 is going to be 1 minus 5 plus 4. 0. No threads. Plug 2 in, I get 4 minus 10 plus 4. That's -2. What do you think? Sketch the graph. That one's not going to work. -1, 10 is like here. 0, 4 is like here. 1, 0 is here. And 2, -2 is here. Oh, shoot. Sketch the graph. Do I have enough there to see the graph?
No.
No.
You add 3 and 4.
Huh?
So on the X part, you put the extra numbers.
On the X part? So, what is the Y-intercept? Well, we can answer the Y-intercept right off the bat, 0, 4. What is the equation of the axis of symmetry? We don't know the vertex at this point, do we? I mean, it's very possible that very bottom point is the vertex, but I would go to the -b over 2a. Negative b over 2a is negative 5. Still with me? That's 5. 5 over 2 is 2.5. So my axis, so 2.5 comma something will be my vertex. But do I have enough information right there to list the axis of symmetry? The axis of symmetry is always x equals what?
Wait, is it, probably, so it would be the same on the other side, wouldn't it?
It would. Yeah.
Yeah, so the axis of symmetry is -2, no,
To what?
to, the axis of symmetry is just 1. 0? Yes, I know. The axis of symmetry, isn't that just x equals something? X equals 2.5.
So the axis of symmetry is the x component of the vertex. Okay? We didn't have the vertex yet. So the vertex goes 1, 2, it's like right here. Okay? We don't know what the entire vertex is. I didn't plug it back in to find it, but we have enough information for that. I mean, we have this graphed right here as far as what our table tells us. Okay? We should have to go further. I mean, theoretically, this graph is doing this over on this side too. I just don't know how far down that's going to go because I didn't plug it in yet. It didn't ask me to. Okay? What are the roots? Well, I know that's one of them. And then being it should be symmetric about the axis of symmetry, that's 1.5, 1.5. So I guess right there, 1, 2, 3, 4. I think that's the other one. How can you get there if you don't have the information? You can try and factor it. Well, I factor down x minus 4, x minus 1. That's a 1, even though I wrote different. So that's x equals 4. Check. That's x equals 1. Check. We're good. Okay, so there's ways of going about answering the questions without actually going through the whole problem. Almost done. We good?
Yeah.
Poke your neighbor in the eye real quick. This is it, buddy. All right. Are the following linear, exponential, quadratic, or neither? 2x squared. What is it? 2x squared. Quadratic, good. Next one, 2 raised to the x. When the x is raised, that becomes exponential. Exponential again. Quadratic. Linear. Cool. Linear again. Oh. Neither. This is a radical expression. This graph here actually looks like this. If I graph it appropriately, it's going to look something like this. That's what it looks like. So we don't have that. This one is what? Linear. This one is quadratic and guys and girls, that is the review. I would say let me hand out the take-home portion of the test. This is worth 25 of the 100 points on the test. Get it right. You have a review to write on. For those of you who haven't figured out and you write down stuff, you could have utilized it as notes. But I do have it all recorded on video on YouTube. Me? I I don't want to have that kind of power because I think it would be fun just to blow things up.
Let's just blow.
You know what I would do? Casey, if I became president, this is what I do. I would put few atomic bombs to the North Pole, and then a whole bunch of them to the South Pole, and just melt all of the ice. That way we could be done with the whole global warming thing, and the ice caps would be gone.
You ever seen
Actually, that's called
It's actually different.
Bunch of glass.
We should be.